Hi, let's keep building our synth here in Max. So this is our voice, and go ahead and open this and open up the console, and this is our main program here for the synth. So what we're going to do now is implement several other waveforms as well as filters. So let's get going. Inside here we have only the sawtooth oscillator, so we're going to implement several more now. So let me just change this quickly here, snap to grid, and so we're going to need to make some space here. And so the basic idea is to create all these waveforms. So let's start with the sine wave. The object in Max here for a sine wave is a cycle tilde, and also the saw that we already had. We can use also a triangular wave. What else? And then a rectangular wave. And then these have other parameters that we might want to change dynamically, but we're not going to do this now. We're going to do this later for sure. And also a pink noise generator, as well as a just white Gaussian noise. And so we can choose between all of these waveforms. And what we're going to do actually is I'm going to bring this media to frequency object here, and the output of this guy here is going to go into each one of these, except for obviously the pink and white noise, because these, they contain all sorts of frequencies and don't respond to this media to frequency number here. And we're going to create another object called the selector tilde, and selector tilde, we got to give it an argument of however many waveforms we have. So we have 6. Let's give it an argument of 6, and then it's going to, depending on a number that we give in this inlet here, it's going to output through this outlet any of these other inlets here. So this is going to be, so it's indexed from 0. And let's create right now a receive object, waveform, receive waveform. And so receive waveform is going to tell selector which waveform to output. So it's going to be either cycle, triangle, saw, rectangular, and pink. It's a little tedious, but that's the way it is. And also, we want to change a little bit the gain, because we're going to have more than one of these guys here. So we're going to have more than one waveform going on. So one thing that we need is a multiplier here for signals, in which we're going to change the gain of each of these oscillators. So let's put here receive gain, and I'm going to create a general model here. Then we're gonna copy that into I'd say 3 oscillators is a good thing, perhaps 4, 3 for now, let's say. And so this is going to be the sand for this guy. This object here is going to be in our main program, and also for this one. And now all we need to do is connect this to an output, and we should be, let's see, 1, and we should be good. This is just a dummy thing. I'm going to delete it in a second. You'll see why. So also, something that we need is a detune parameter, because if we're going to be generating 3 oscillators, it's interesting to have them not at exactly the same frequency. So that's why we brought over the media to frequency into this little abstraction here that we're going to make in a second. So this we're going to actually add here a little multiplier, and let me just say here receive detune, and so we're going to multiply the output of the MIDI to frequency, which comes from the keyboard, by this detune factor here. So let's just create a, so now a simple multiplication. These are not signals. These are not going to run at audio rate. So let's just copy all of these. By the way, to select the chords, you hit the Option key, and you select all of them at once. Move to this guy here. So we're going to actually multiply that, not the frequency, but we're actually going to multiply the MIDI note. That's what we want to multiply. Let me see if I did it right. So yeah, so we actually we need the MIDI to frequency later in the chain. Let me just undo a couple of these, and yeah, so we're going to multiply whatever comes from that. Let me put a dummy inlet here. So whatever the MIDI note, we're going to multiply by some detuning factor, and then we're going to convert this into a frequency. Okay, so this makes more sense. Okay, now we're going to generate several of these. So let me go ahead and encapsulate this. To encapsulate objects, we hit Command Shift and E. So this is going to create, whoops, there's something wrong. Yeah, I shouldn't have selected this guy here. So the inlet and the outlet should be out of the encapsulation. And let me just remove these and encapsulate again. And oh boy, I forgot. Now let's go. If I don't go full retard again, then this should work. Okay, good. Now we have, that's why I created these dummy inlet and outlet, which we can delete now, and we're going to call this oscillator later 1, oscillator 1. And now we're going to actually edit this inside, double click to open it, and we're going to sort of change. So receive detune 1 and receive waveform 1 and receive gain 1. Nice. Okay, so we can save, close this, and then we can duplicate this guy here. So let's duplicate it, and this is going to be oscillator 2. And in here, we're going to also change this to detune 2, gain 2, and waveform 2. Beautiful. Let's keep going. Another one of these. Let's do 3 for now, and then we can do 4 if we want later. But for now, 3 should be a good proof of concept. And so this is going to be our oscillator number 3, and detune 3, waveform 3, and gain 3. Okay, cool. So let's so instead of this sawtooth and MIDI to frequency, we're going to actually use these guys. So we can now delete this, and move these 3 in here. Let me just make a little more room. And so now we're going to send the frequency to all these oscillators, and then put them all in here. Okay, oops, no. So we're gonna, by sending several chords to the same inlet, we're in effect summing them all together and then multiplying by this envelope thingy. Okay, now let's go ahead, save this, and move on to our main program and implement all of those controllers that we left sort of hanging behind. So as I said, we're doing this inward. So we're building them. We're going bottom up from the sound source to the controls. Okay, so now what we had was a waveform. Oops, no, that's not what I want. We had we need to sand waveform. Oops, waveform 1, 2, and 3. 2 and 3. And we need to sand gain 1 and gain 2 and gain 3. And we also need to sand the detune 1, the detune 2, and the detune 3. Okay. So I'm thinking we're going to end up doing filters in the next video because this is already getting pretty long. And so we're going to use other menus here to choose the waveform, but we're going to actually hit Command I to inspect what's in those lists. And so here, the waveforms that we've chosen are sine, so triangle, sawtooth, and then rectangle, and then pink noise, and white noise. Okay, so, and so we need 3 of these. And now this is we actually need the number here because the selector object takes a number as an argument. So we're going to use the first inlet. But this indexes from 0 and 0 being off, an off state. We don't want it ever to be off. So we're going to actually add 1 to the output of this thing. So let me just show you real quick here. We can say put an integer box there to see what's going on here. And perhaps another integer box to see what's going on without the +1. So in effect, instead of a string like in here, this guy here's the first outlet's actually outputting numbers, which is what we need for the object that we're sending this to. Okay, so cool. Let me just delete this, and we should be looking pretty good here. Let's do the other ones here pretty quick, and duplicating these things. Lots of connections, but we're good. Okay, now we need some gain. Let's create some object that will manage gain for us, say a dial, no, not a DLUB, but a dial. And we're going to also inspect this guy here. This the number of steps here is between 0 and 28. We want it between 0 and 1. And actually we want a float output and want it between 0 and 1. So now we can duplicate this 2 times. And so we're going to use these to control the gain of each of the oscillators there. Okay, so we're going to send to the gain 1, send this to the gain 2, and okay, so already we have 1, 2, 3, 4, 5, 6, 7 user interface items. Then later we're going to get rid of all these things that are 8 and 9. So we're going to get rid of all these things that are not essential for the user and concentrate on building a nice user interface. Now the detune, perhaps we can use another set of dials here, but now I want the detune to go between plus and minus 1 octave, right? So an octave in MIDI steps is equal to 12 steps, so we need 24, say 25 steps, counting with 0, so 25. And we don't need a flow output, but the minimum value is going to be minus 12, right? Nice. And this all looks pretty good. and no, and now let's put this here and duplicate it twice, and one goes there. This guy goes here, and we can move this down a little further, and let's say, so this goes to detune 1, this goes to detune 2, and this goes to detune 3. Okay, so let's see if all is operational. So audio is on. Let me turn this down a little bit, and so let's select, say, triangle, sawtooth, and square, and let me turn on. Yeah, I'm not hearing anything, but you should be hearing something there, and also something's not turning on, and so, yeah. Oh, now I'm hearing something. Yeah, there's an error here. What is going on? Yeah, let me just turn this off for a second. And all notes off. Do we have an all notes off? Okay, let me just close this and restart. Let's see what's going on. And should be working though. 64. Oh, okay. So let's let me do something here. Let's reduce this to 16 and give it an argument of voice stealing at steal 1. So let's turn on voice stealing. This is probably a good thing to do now. And let me see. So we have 3 oscillators, and we have an ADSR envelope, receive waveform, receive detune, which you're going to multiply. Okay. And oh, I see what I did wrong. So we're not multiplying. Okay. So let's so let me click here, object, open the original. We're not multiplying, we're adding. Sorry, my mistake. So we're going to add, since we're dealing with MIDI notes, we actually need to add here. Okay, so add. So we're going to add plus or minus 12 to these guys. Right? If we were dealing with frequencies, then we would probably want to multiply. But since we're dealing with MIDI notes, then we're going to add. Okay. And here, another one. So, sorry. And add. Cool. Sorry about that. So this should do it. And so let me say detune 0 and detune 0, detune, and then say plus or minus 1 or 2 or something like this. And arguably we might want to change this detune because these detunes here are moving in semitones, so we might want to change them now to reflect the fact that we might need smaller steps than semitones. So let's give it a flow output. So this might be actually pretty important. Okay, and so the gain here, say so gain here is between 0 and 1, and also something pretty annoying with these dials is that it's arguably better to have them as let me see here, vertical or circular. Let me put it circular. I think it's going to work better. There's one of them that I don't like. I don't remember which one it is. Okay, and so now instead of sines, and then later we're going to initialize these things, but for now with some low mass objects, but let's say a little pink noise, not too hot, some a lot louder rectangle, and some saw, perhaps not so much. And let me turn this down a little bit and let's see how it goes. So this is what we want. only a slight detune. A slight detune will go a long way. Good. Nice. So in the next installment, we're gonna, and obviously we can change these things. Say, a little bit more. Obviously the detune here is not gonna take any effect. Perhaps we can change. All right, this looks pretty good. There's one last thing that I would do here is the fact that in all of these things, when I change the detune, it doesn't change the frequency unless I hit the note again. So we're gonna change this pretty quickly. This has to do with triggering things in that addition box that we created. So we're gonna go here again, and so whenever I receive the problem is that this inlet here triggers the computation, and this one here doesn't. So we need something that we need to put something here in between that will trigger the computation whenever we receive a number from here. So we're going to use an object called trigger, and then we need something called a bang, which is a bang is just an impulse that is going to trigger this computation. So the first thing that we receive, so in Max, the order of operations is from right to left. So the first thing we need is to receive a float, and then after we receive a float, we're gonna send a bang. But instead of saying trigger float bang, because of the order of operations, which is reversed, we have to say trigger bang, bang, float, and F. Okay, so this is gonna pretty much, as soon as we receive a float here, right? Sorry. Now this is not what I want. Yes, this is exactly what I want. As soon as I receive a float there, right, it's gonna first output the float and populate this object here, and in a split second, it's gonna output a bang that is gonna trigger the computation there. So this is exactly what I want. I'm gonna copy this and save and move on to the other two here, and just space these, and we need, let's be quick about this, and then snap to grid, and so whenever I receive a float, I'm gonna just pass that float onto the box, but then I need to trigger the calculation there, and now the same thing for oscillator 3. So these are a little of the perks in Max. Don't be alarmed, this is perfectly normal, and it's just the paradigm of the program. So here, and then as soon as we receive it, we're gonna trigger the computation. All right, so this is looking pretty good. So let's reinstantiate this guy by just deleting it and undoing that, and audio is on, close the patcher. So now we probably need to redo everything here, and send a little detune, a little gain. And perhaps a rectangle, and sawtooth, and some. So now they change dynamically, right? So now you see that this is not outputting a float. So let's inspect it. It should. And is float output, float output, float output. And oh, I know what's going on. There's still one more thing to do. It is outputting a float, but the other object that we have is not processing it as a float. And let's go ahead and open this up again. And now this, we need to give some argument here, say 0 dot, so that it knows that we're gonna use floats as our operation, as our inputs. Otherwise, it will perform the calculation with integers, which is really not what we want. We don't want to hear semitones. We actually want to hear smaller steps than semitones in our detune. Okay, so this should be it. And okay, for the love of God, now just work. And a little gain. There you go. So that's exactly what. Oh. Okay, that's it. So the next one, I'll do filters. All right, see you later.